So this is something called a rational expression. Sometimes people call this a compound fraction. Compound because you have fractions within a fraction, right? If you just had a compound fraction any other day, okay, even in middle school, I'm just going to do this little guy on the side. 5 over, now let's say over here I had something like 2 over 7 plus, let's say I have something like 3 over 4. Can you guys all see that this is still a compound fraction, right? This one just has polynomial expressions in it. This one just has numbers in it. Got it? So far, following me? Okay. Now, when you have a rational expression like this one, what is it that you maybe did in middle school, algebra 1, wherever you saw expressions like this? Do you remember what you did to clean this up? This. All right, Callie, what do you remember?
Like for the fraction, when you would like make them have it equal to like same denominator.
Okay. Yes. Did anyone else kind of maybe have that thought, something to do with common denominators in here? Okay, so common denominator is often a way that you were shown how to handle this. So I'm actually going to show first this question 2 different ways, and then we're going to apply the easier logic to this problem, okay? So Callie is saying to find a common denominator in the denominator, right? So that means I'm going to leave the 5 alone, and in the denominator, what will my common denominator be? What will your common denominator be in your denominator? 28, good. So what would you do with the 2 sevenths to make it have a denominator of 28? Multiply by 4, or how else can we rephrase that a bit? Better, 4 over 4. I know a lot of time you guys got away with saying things like that, multiply by 4, because like people knew what you meant, you knew what you meant, but when you say multiply by 4, you really mean multiply by 4 over 1, but you can't just multiply a fraction by 4 over 1, you're changing its value, has to be 4 over 4. So this gets a 4 over 4, and what does this get? Yes, 7 over 7. Once 2 fractions have a common denominator, we will be allowed to add them. So 4 times 2 over 4 times 7. What do I write down as my first fraction down here?
8 over 28.
Good, 8 over 28. And what do I write down for my fraction over here?
21 over 28.
Perfect, 21 over 28. From there, we add the numerators only, right? It's not like you add the denominators and get 56, right? You just add the numerators. 8 plus 21, anybody?
29 over 28.
Good, 29 over 28. Now, anytime you write a fraction like that, can you see it's like a little confusing, like who's the main fraction bar? So always make sure you don't lose track of that within your own work. So it will make a difference. You could probably learn like same change flip when you divide by a fraction, right? Does that sound like something you did? Okay, so make sure you realize that this piece is the denominator. So if you have learned same change flip, or maybe you just learn it as when you divide by a fraction, you multiply by the reciprocal, right? Yes? Okay, so that 5 is really a 5 over 1 times 28 over 29, and what does that leave us with? 5 times 28, anyone? 20 times 5 is 100. 8 times 5 is 40. 140? Say it again. I think it's 140, right?
130, actually. 140.
140, yeah. Over 29. Done. Okay? A little low down here. Sorry, a little squeeze. Okay, so that right there is the way maybe some of you learned to do it. Does that look familiar? I know maybe the numbers are bigger than what you had when you were younger, but concept process-wise, we're on board? Okay. Did anyone learn a different way that maybe it came back to you while I was going over that, or no? Nothing? No? No one wants to risk it? Okay, so I'm going to show another way, which I think is much easier. I may have spoken of this way earlier in the year with other types of things. I can't remember right now. But over here, I just erased my work in the original problem. All I'm going to do is I'm going to put big parentheses around the top and big parentheses around the bottom. I'm not a big fan of this way because to me, this is messy. Okay, a lot of writing and a lot of place to make mistakes. Now, same idea with the common denominator, right? What's the common denominator of now all the expressions separately? 5, 2 sevenths, and 3/4. It doesn't really change, right? It's still 28. Can everyone agree? So instead of multiplying this on top and bottom by something individually, I call this the hamburger. So it's like normally I would have like a big parenthesis on top and bottom. So it's like these are the buns, and this right here is the hamburger patty. All right, so I made it into a hamburger. Now I'm still going to multiply by 1, but the way I multiply by 1 is I multiply by 28 over 28. No matter what, as long as you multiply by the same thing on top and bottom, that's 1. Now, next step. What's 5 times 28? Well, we just did that a second ago. What's 5 times 28?
140.
That's 140. On bottom, I'm going to take that 28 and just distribute it to this and this. But it's important that you remember, and it always comes back down to that whole concept of prime factorization, that you don't forget that 28 was made of 4 times 7, right? 4 times 7 right there. Okay, if I multiply 28 here, I'm distributing it. That's why we have parentheses. What happens when I multiply 28 by 2 sevenths? What happens when you multiply 28 by 2 sevenths? Daniela, what happens? Well, okay, ready? There's a reason why I picked to do this way instead of this way. You're not going to get really big numbers, okay? 28, if you remember, is 4 and 7, right? That's really what 28 is. It's even 2, 2, 7, right? Because 4 is 2 times 2. Can you see that? When you multiply, if I just wrote on the side the 2 sevenths part, so 2 sevenths times, if I just wrote 2 over 7 times 4 times 7, what could you do to this? Everything over here? I get big numbers. Can anyone think of something to avoid having to multiply all of it, Emma? We can reduce the 7s, right? So that's the benefit of my hamburger method here. You're going to avoid, so you would have seen a 28 somewhere. I'm sorry, what did you say, 56 somewhere? Because you would have had to do this times this. And these numbers aren't even that big, right? Numbers can obviously get worse. So 28 times 2 sevenths, the 7 will go into 28 evenly. How do we know that? We picked 28. We made it out of that number, right? We used that number and that number to make it. So 28 with 7 reduces, and I'm only left with 4 over here and 2. And what's 4 times 2? That's 8. So there's the 140 on top. Here I have an 8. Now, distribute this. 28 times 3/4. So Danielle, let's try to redo. We were able to reduce the 7 when we distributed here. What can I reduce when I distribute it here? And what's left is just, and, which is, and then what's 8 plus 21? Done. Can you see that the second way I showed you is going to be a lot cleaner? You see, like, even comparing just side by side right now, this is 140 over 29, and that was the work. And then we get the same answer, but that was the work, right? Now, showed you all this. Let's go back here, okay? This problem is the same thing. When we get into higher algebra, it's the same stuff, just on a bigger scale. I'm going to multiply my hamburger over here on top and bottom by the same thing, okay? What's the least common denominator of 1, x plus 2? X plus 2 is like my 7, and x plus 3, which is like my 4. I need to multiply on top and bottom by the same thing, right? So Nadav, what should I multiply on top and bottom by? I need to multiply the numerator and denominator by the same thing, just like the 28. I made 28 out of the bottoms, the denominator. Okay. How did you get 2x plus 5? You added those, right? Did we multiply by 11?
Oh, 6, sorry.
Did we where's 6?
So 3 times 2.
You multiply, that's how you multiply this times this?
Oh, you have to multiply.
How do you multiply this times this, Nadav? I know you know. Okay. Now that would be like making it into 28, right?
Yeah.
But I could have, instead of writing 28, couldn't I have just done this? Right? And never even had to multiply 4 and 7? Like, I don't actually have to write 28 to have 4 times 7. So let's do the same idea here. Ready? You guys don't even have to, Nadav was about to tell me to FOIL this, right?
Yeah.
So instead, all I'm going to do is I'm going to write x plus 2 and x plus 3. And here, same thing, x plus 2 and x plus 3. So really, as long as I multiply the top and bottom by the same thing, I'm multiplying by what number? 1. Now, in the numerator, 1 times this times this. Well, now maybe is a good time to FOIL. So if I FOIL this out, Vika, what do I get?
X squared,
Mm-hmm.
plus 5x
Yep, 5x.
plus 6.
Good, that's my numerator. Done. 1 times this times this. All I did was FOIL. Bottom, ready? If I distribute this to this, what happens, Zeke? This times this. Remember, we did the same idea here. We did this times this, and it cleaned up nicely.
You get x plus 3 and x plus 2.
Those are both there if I multiply by this. I'm just looking at this term times this.
X plus 3.
Right, does everyone see you'll only get x plus 3? So that's x plus 3. Then I have this plus sign, don't lose it. Plus, Doug, if I distribute this times this, what do I get?
X squared.
This
The whole thing.
times this.
Yeah.
Remember, when I multiply 3/4 times 4/7, or not 4/7, 4 times 7, the 4 crossed out. Because you have 1 on top, this is over 1, and 1 on bottom. This is to clean up our messy compound fraction. You will not have a compound fraction when you're done.
Can you cross out 3?
Well, not 3, but
X plus 3.
yeah, that whole quantity. You can't cross out part of it. So x plus 3 and x plus 3 are gone when I distribute it here, and what's left is just good. And remember, it's addition in between. Last step, maybe we leave the top the way it is. It's already in sort of standard form there. X squared plus 5x plus 6. What could I write down in the denominator page? What could I write in the denominator for the next step? If this is the previous step for my denominator, this is my fraction bar. How about that? 2x plus 5. Done. Now, did anyone choose that option? Did anyone? We have 1, 2, 3, a few people. People that did. Did you sort of do it more this way, where you found a common denominator on the bottom? Serene, you said yeah. Anyone else? Who else said they picked that answer? Did you sort of do it this way? Like where you found the common denominator on the bottom and flipped and multiplied? Okay, but can you guys see that this is much cleaner? Okay, more efficient. So that is the first question there, okay? That was the answer, and I forget which letter that was. Do any of you remember? B or something like that? Okay, there we go. All right, last thing to say about 13. What's the domain, or what are my restrictions here? So let's go way back to domain and range. When we did domain and range, we even talked about domain and range from equations, and we said that's one of the harder things to do. So what can you tell me about either domain or restrictions, Paige?
X can't equal -2.
Good, I like that. She said x can equal -2, because then I'll have a denominator equal to what?
0.
Good, and that's not allowed. She said x, so I'm gonna write those on the side over here, just in another color here. So she said x cannot equal -2, because of that. And she said it can equal -3. Is there another sneaky number that x cannot equal in this problem? Tatiana? Almost. Don't jump to conclusions. How do we get -2? What are you really doing to the denominator to solve? We keep doing it to these expressions all the time. Zeke, what are we really doing?
Oh, I was going to say,
Well, tell us what to do first. I believe that you will say the right answer in a second.
setting to 0.
Set it equal to 0, right? So you see that you just said -5 because like we get into a habit of just looking for the opposite of that. So then she jumped to the opposite of that. And a lot of you guys do that. So we're going to set it equal to 0. So now, Tatiana, what answer would you pick? And Zeke's going to tell you if you're right or not. Okay, Zeke, is she right? You heard what she said? You're just guessing.
I think she said,
Say it louder, Tatiana. -5/2? Yes, she's right. -5/2. So really, we look at every denominator along the way. None of them could equal 0 because you're not allowed to divide by 0. So those are just some bonus restrictions to talk about. All right, and that's the end of that. Again, here I'm showing you an example where I'm not even giving you directions. We're just going to go with our math instincts. What can we do with this? What am I looking at on either side of this equal sign? Brad, what am I looking at? Use math words that we use in class all the time to describe what either the left is, the right is, both of them are. You know words for it. Don't be afraid. They're both polynomials. Can you be more specific? Yeah, they're both quadratic. Okay, so far he's right. What's the difference between the forms that they're in?
that's factor.
Factored form, yep, and standard form. Everyone agree with him so far? So far, so good? So we have factored form of a quadratic and standard form of a quadratic. We should, at this point in the game, be really good at going either way, right? If I give you this, you should be able to make this, right? And if I give you this, you should be able to make that. How do you go from this form to this form traditionally? FOIL, sure, expand, multiply, distribute, whatever you want to call it, but yeah, FOIL's fine. And how do we go from this form to this form? Maybe AC method and grouping, right? So which one's going to be easier to do right now? Is it easier to FOIL the left, or is it easier to try to factor the right?
Factors.
How would you, okay, pick whoever wants to defend their side. Which one? I heard someone say factor the right is easier, and some people I heard say FOIL. Tatiana?
Maybe you should FOIL because then they're equally considerable.
Okay, good. So she says let's FOIL, so when we simplify, when we have it open, we could simplify even more, and I agree with her. Because how would I factor this? First of all, AC method, step 1, 15 times 14, ew, too big. Second step, even when I find AC, I have to find two numbers that multiply to get me whatever that is, and add to give me C. I don't even know what C is, right? Like, how are you going to do that? Can you guys see that you would get stuck? So it's going to be easier to do this. So if I FOIL this, Gus, what do I get for my first term? Yes, a, b, x squared. Even though it looks different, doesn't mean you can't do it, okay? You guys can do it. You're just scared because it looks different. All right, outer. What do I get for outer, Ellis?
7AX.
Perfect, 7ax. Taya, what do I get for inner? 2bx. And what do I get for last, Angelo? Last times last. So we're foiling this out. Gus did first times first. We got this. Outer, Ellis got us 7ax. Inner, Taya told us 2bx. And now we're doing last times last. Yeah, that's it, just 14. So the other ones were messy. So then when you get to an easy one, I feel like you're suddenly like looking for the trick. Like, wait, hold on, right? Do you feel like that's kind of what you did? Yeah, so all the other ones had A's and B's, but this one was not affected by that. Now I'm just gonna rewrite the right-hand side, carry it down along with it. Now Tatiana said we're gonna be able to simplify once we expand. Once they're both in standard form, do you see that now they're like, you've leveled the playing field? You now have two equations in standard form on either side, okay? Looking at the left and looking at the right, what else can we do Elise, if we look at the left and look at the right, if this was something in front of you, what is something else we can do with this? Sure, get rid of the 14. If you might say to yourself, well, they both have one, so I'm going to get rid of it. Or maybe you just say, I'm going to subtract 14 from both sides. So, well, that's gone. Okay? Now, staring at this, give it a good stare. Usually, when we FOIL, what happens to our outer and our inner? Chris? They add together and give us the middle. Remember we did FOIL, and I showed you FML for middle, right? So these two usually add to give us the middle. And then this term, what is the name of this term using those polynomial words we have? What is the name of this term? It's your blank term.
Leading.
Sure. What other word? Starts with a Q. This starts with an L. This starts with a C.
Quadratic.
Quadratic term. So my quadratic term, ABX squared, has to be this. Do we all see that this is this? Can we all agree? Yeah? And then can we all see that this has to be that? Can I write anything down? Maybe you did it in your head already. But can I write anything down that's true without any X's being involved? What can I say about A, B, and C? What's one thing I could say about A, B, and C? Can you give me one thing? What has to be true? Jenna, what can we say about A, B, and C? Can we make up any little equation? Maybe it's just about A, maybe it's about A and B. What has to be true? This is your quadratic term, and these are your linear terms.
A times B equals 15.
Perfect. Does everyone see A times B has to be 15? Yeah? Okay, and then Zareen, what else can we say?
I was just going to say the problem also tells us that A plus B is 8.
Oh, it tells you which one, A plus B? Okay, we'll get to that one in a second. And then, so what else can it tell us? We took care of this part. This is equal to this. What else can we say? Left with this information. Tatiana?
I was just going to say A plus B equals C.
A plus B, say it again. Not fully A plus B, because you have this here. These are involved. We're dropping the X's, yes, but these we said are going to add. So I know what you're thinking. These add to give you this, but Vika, can you fix a little bit what she said?
7A plus 2B equals C.
Better. 7A plus 2B, because 7A is the coefficient, and 2B is the coefficient, has to equal C. So far, still with me? So that has to be true. Next, Zareen told us the problem said, so this was us working without that information, right? Zareen says the problem also tells you that A plus B equals 8. Okay. Now, looking at this and looking at this, can you make any conclusions about A and B? 3 and 5, right? But do you know which one's which? We don't really know for sure, right? That's why. What did you notice about the multiple choice options? Gus, what did you notice? Yeah, there were 2 numbers because we could do it both ways. Let's put in where A is 3 is A, and 5 is B, and then vice versa. And then they wanted to know what's the value of C in that case, right? Now, this was very more or less formal. If you filled in 3 for A and 5 for B, this would be true. Then you fill it in here, 3 for A, 21, right? 7 times 3, plus 5 for B, 2 times 5, 10, is C. 21 plus 10 equals 31. And that was definitely an option, and it was only in one of the 4 options, so really, you're done, okay? Did anyone pick the answer that had 31 in it? One person? It was like 31 and 41, I think. Okay, so now I'm going to look at this one other way. Ready? Maybe, what if, as soon as you looked at this, you were like, what times what is 15x squared? And your brain was like 3 and 5. You're fine for thinking 3 and 5 or 5 and 3, but don't forget 15 and 1 would work, and 1 and 15 would work. Okay? So you don't want to forget that and jump to any conclusions, but it would have worked out for you in this case. Then you read what Zareen saw, A plus B equals 8, and you're like, oh, definitely 5 and 3. So I'm going to do this one this time, saying 5x plus 2, so I did A equals 5, and 3x plus 7, right? Now I have a real fully finished factored form, and this is just standard form, and they're asking me what's C, so I'm like, all right, I'm just going to FOIL. First, well, that's obviously 15x squared. That's how I pick those numbers. Outer gives me what? Gael? 5x and 7x, so
15x.
don't listen to him. He's lying to you. He's yelling out random numbers. I'm foiling. I just did first times first. I got this. I need outer.
35x.
35x. See how trusting you are? The job. You just said it in his brain, like he automatically spit out what you said. All right, inner.
Inner, 6x.
Yes, plus 14. Now, use that, though, honestly, guys, as an example, like how influenced you guys are by what you hear. Like, right, you were trusting and even if you didn't know what the heck he was saying, like, you automatically just said it. So it's like, when you guys have other things, like you're listening to a conversation or music and doing your work, you're going to make mistakes. Like, if I hear, do you ever write down a word you hear someone say?
Yeah.
Like, what the heck am I doing, you know? So make sure, clear mind when you're doing your work. All right, and then here, 35x and 6x is that 41x. So you would have gotten that C equals 41. Okay, so those were two questions. 13 and 15 were the numbers that they were. I think they were both in a non-calculator section of an SAT, which would mean that they were towards the harder end of questions because the multiple choice is 1 through 15. So 1 being the easiest, 15 being the hardest, and then 16 through 20 are the open-ended. And it resets easy to hard. So these are a little bit maybe harder questions, but if you can get something like this right, or you could at least narrow down your answers with process of elimination, well, then you're a big winner.